Hey everybody, I wanted to work through ChemActivity B, and I'm going to go ahead and start doing that. This is on page number 53. I'm going to start with model number 1, looking at some binary compounds, some examples, and breaking them down a little bit. Now the first example that was provided to you was calcium chloride. Now calcium chloride has the formula CaF2. One of the things that you'll notice by this is you'll notice you'll notice a subscript of S. Specifically, you'll notice the S next to the full name of calcium chloride. That's an indication that this is a solid. So whenever you look at this, what you need to do whenever you look at a formula is you need to discern what is it made up of. This is made up of calcium and fluoride. Okay, so where are these two different elements? Well, calcium is on the left-hand side of the periodic table. This is a metal. So the right-hand side of the table, you'll notice fluorine. Fluorine is on right here, and this is a non-metal. So the combination of a metal and a non-metal, in this case we have one of each, this is known as an ionic compound, and is therefore not a molecule. So for the question of is this a molecule, yes or no, the answer is no. Now, if you look right here in the center, you'll notice the kind of breakdown of metals versus nonmetals. There's a divider basically right there. I got this periodic table from ptable.com. You're welcome to look at that. Okay. Next up, not necessarily the next in the notebook, but the next example that I want to do is magnesium oxide. Okay, so where are these two different components? Where's magnesium? Magnesium is right here, whereas oxide, well, oxide is oxygen. Now, we can go ahead and put our metals. Our single metal is Mg, and our single nonmetal is oxygen. We have a metal and a nonmetal, so this is an ionic compound. So is this a molecule? No, it is not. Okay, what's our formula? Well, how are we going to figure that out? One way that we can figure that out is in this group number 2 right here where our magnesium is. This is an atom, or this is an ion that forms a +2 ion. Group number 6 here, where oxygen is found, those form -2 ions. Okay, so how do we pair those two up? Think about this as this has given up 2 electrons and oxygen wants to gain 2 electrons. So they actually meet up where their charges, Mg2+ and O2-, those two charges, 2- and 2+, they would basically cancel out. So MgO, sorry, my O is a little bit silly there, that is our formula for this compound. Next up is nitrogen dioxide. Okay, so let's start from the left. Metals, or I'm sorry, nonmetals. Well, on the right-hand side of the periodic table, that's where we're going to find our nonmetals. We've got nitrogen and dioxide. So we've got nitrogen, which is a nonmetal, and we've got oxygen, which is also a nonmetal, so NO. Okay, what do we know about these two different substances? Well, do we have any metals? No, we do not. Okay, so is this a molecule or not a molecule? This is a molecule because this is not an ion. Now, what does this tell us? How do we pair these two up? With an ionic compound, it is kind of simple and straightforward. You balance the charges. Well, what we get with a molecule is a little bit of information. This this prefix right here, dioxide, Di, that tells you that we've got 2 oxygens. Now, do we see the same sort of prefix in front of nitrogen? No, we don't. So our formula is nitrogen and then oxygen, and we use a subscript of 2 to explain that. So NO2 is our formula for nitrogen dioxide. So we use that language or those prefixes when we're talking about a molecule but not an ionic compound. Next up, aluminum oxide. Okay, so aluminum and oxygen. Do we have any nonmetals? Yes, we do. We've got oxygen as a nonmetal. Do we have any metals? Yes, we do. Aluminum. Notice we've got this divider right here, but where does aluminum fall into that? Aluminum falls as a metal. So our metal is aluminum. Okay, now is this a molecule or a compound? This is going to be an ionic compound, so it is not a molecule. Okay, Now, since this is an ionic compound, how do we figure this out? How do we figure out the formula? Well, being in group number 13, this is a +3 ion. Being in group number 16, oxygen is a -2 ion. So we've got two different charges there. So Al +3, O2 minus. What you can do is you can kind of match these up by taking the superscript charge for one atom and making it the subscript for the other atom. The superscript charge for the aluminum atom becomes the subscript for our other atom. So our formula, therefore, is Al2, we don't use the minus, O3. Think about it as aluminum is bringing a total of, or there are 2 aluminum, and they are each bringing a +3 charge. So 2 times +3 equals +6. We want to have this be a charge-free molecule, so then we have 3 oxygens that each have a -2 charge. So 3 times -2 equals -6. So with their powers combined, we get an overall charge of 0, which is what we want. So Al2O3. Now, our last molecule, disulfur decafluoride. We're starting over on the right-hand side. Metals, or sorry, nonmetals. I'm going to draw my line so that I can distinguish between my metals and my nonmetals. What are my molecules? I've got sulfur and fluoride. Now these prefixes should be a good indication that we're probably going to be using, there are going to be subscripts involved. Likewise, those prefixes are a good indication that you're talking about a molecular compound. But let's look at the different components. We've got fluoride and we've got sulfur. Where are those found? Those are both on the right-hand side of my line. Those are both nonmetals, S, F. Okay, do we have any metals? No, we do not. So is this a molecule? Yes, it is. This is not a molecular compound. Okay, so now what do we need to do to figure out our formula? What we need to do is look at our prefixes. Disulfur, Di means 2. So we have S subscript 2. Now deca is 10. And that's something that you do need to commit to memory. What are these prefixes? But what does that mean for our formula? That means we have a total of 10 fluoride. So S2F10. And that's our formula for disulfur decafluoride. I hope this was helpful.